law problems and analyzing financial flows. Okay. As we move on, today we're going to talk about nonlinear flows and how that changes our calculations just a little bit. Okay. So let's look at an example. We'll start out with a linear flow, and then we're going to transition this into a nonlinear flow. Okay. So our example comes from our textbook 356, and I'll just go ahead and read what 356 has to say. Okay, so that's on page 59 of your textbook, and so we're talking about Automoto, which is a financial service, and it provides financing to qualified buyers of new cars and motorcycles. So having just revamped its application process, Automoto is now evaluating the effect of its change on service performance. So what we know is that Automoto receives about 1,000 loan applications per month. Inventory, throughput, or flow time? Throughput. Applications per month. Okay, we're going to assume that there's 30 days in a month. Okay, they accept, reject decisions based on an extensive review of each application, and so we're going to assume that just so we can convert into days that there's 30 working days in a month, and they typically approve 20% of their applications and reject 80% of their applications, and there are a total of 500 applications in process on average. Inventory, throughput, or flow time? Inventory, right? So if we were to look at what that looks like if we draw the diagram, right, we have 1,000 applications per month entering and exiting the process, okay? And if we have 20% that are accepted and 80% are rejected, on the outbound side, we have 200 that are approved and 800 that are rejected, okay? And we have this individual review process. Every application comes in and goes through the same process. All right, so there's only one step in this process, right? So when I create my table, I'm just going to put individual review, and I look for inventory, throughput, and flow time. I know that we have, on average, 500 applications. I know that we have 1,000 applications per month, right? And so if I were going to then, let me go ahead and pen this in. So then, if I'm going to convert my throughput to days, right, I'm going to take 1,000 and divide it by 30 days. And that's going to tell me that I have 33.33 apps per day. And you only can know what that says because you heard me say it, not that you can read that apps per day. But that's what. So again, I know that I've got 33.33 apps per day. If I'm interested in the flow time of that process, right, I'm just going to use my table of inventory divided by throughput. So 500 applications divided by 33.33 applications per day leaves me with 15 days. All right, so we've looked at just this linear process. It's one step, right? And every application goes through that exactly, okay? So then they went on to say that because the percentage of approved applications is fairly low, they are making a recommendation that there's an initial review team be set up to pre-process all applications according to strict but fairly mechanical guidelines, so I can look at it and make a quick decision on what needs to happen with it. So each application would then fall into one of three processes. A, it looks excellent, right? B, I think I actually got this on a slide so you can follow along with me. B, it needs more detailed evaluation. C, we're going to reject it summarily. Right? A and B applications would be forwarded to a different specialist group, and each subgroup would then evaluate the application in its domain and make accept, reject decisions. Okay? So here's what that revised process looks like, right? So I still have 1,000 applications per month entering this initial review stage, okay? But I've got 25% that are excellent, that are going to go through the excellent review process. I've got 25% that go through the detailed evaluation process, and I've got 50% that we just immediately can say that's not going to happen, right? So they don't go through any other process, they're just immediately rejected, okay? And so we still have 1,000 applications per month going through the initial review process, okay? If we say that 25% of those go through the excellent review process, right? I can take 1,000 times 25%. This is where we start to get different, right? We're not every application isn't going through the same process now. So we have to adjust our throughput. So not only 25% of these are going through the excellent review process, so that means 250 are going through the excellent review process. 25% are going through, right, the detailed review process, and then 50% are being rejected outright. Okay? And so that's how we then revise our throughput. And we need to convert that throughput again into days. So what I'm going to do is divide everything by 30 days, right? So I'm going to take each of these and divide by 30. And once I do that, right, 1,000 divided by 30 is still 33.33. 250 by 30 is 8.3. Okay, and 250 divided by 30 is still 8.3. And 500 divided by 30 is 16.7. Okay, so now I have my throughput for each of those steps, right? And so then the problem tells us that we have 200 in inventory at the initial review. So I can put 200 here. And it says I have 25 in inventory with the excellent review. And I have 150 with the detailed review, right? And so how many do I have in this rejected outright? It's a trick question, right? There aren't really any there because they just pass right, they bypass that, okay? So there is going to be, if I take inventory divided by throughput, right, there's no time with this because it actually occurs at that initial review and then it's just done, okay? But I can take then and calculate my flow time and say inventory divided by throughput, 200 divided by 33.3 is 6 days. Okay. 25 divided by 8.3 is 3 days. Right? And 150 divided by 8.3 is 18 days. Okay. And then rejected outright, 0 apps divided by 16.7 is 0. All right. So then here's where things become a little bit different in a nonlinear process. Okay? If I want to understand how much inventory is in the system, I can still sum up the inventory at each step in the process. And that's still a valid approach. So how much inventory is in the system? 200 plus 25 plus 150. So 350, I think that's 375. Okay. And if I'm interested in the throughput for the entire system, what's the throughput for the entire system? 1,000, right? So I still have 1,000 coming in and I still have 1,000 exiting. They're just going through different steps as they exit. So this is still going to be 1,000 applications a month or 33.33 applications per day. Okay, so if that's the case, what's different is I can't sum up my flow time because not every application goes through every step. And so if I were to try to sum up my flow time, I would overstate how long it takes on average for something to go through. So I have a couple of choices, and we'll probably go with the easier one, but I'll show you the longer way first, right? So one of the choices I have is I could do a weighted flow time. So I could say that I have 1,000 applications, and basically 25% of them are going through the excellent review process. So if I were trying to determine how long it takes for each one, I would say, well, I've got in the initial review, what percentage of my 1,000 applications go through the initial review? 100% of them, right? Every single one of them. So I could take 100% times 6 days, okay? Then what percentage of my applications go through the excellent review?
25%.
25%. So I would take, if I'm trying to do a weighted flow time, then I would take 25% times 3 days to give me the weighted flow time for the excellent review. I would take 25% of the weighted flow time for the detailed review, and I would take 50% of the weighted flow time of the rejected outright, which is 50% of 0, right? All right, and so what that looks like then is this, okay? So we've done our weighted average, and then we can say that what our average flow time is. So the flow time for an excellent accepted is that we have, it spends 9 days in each category, and we have roughly 175 applications that flow through that process, okay? So our weighted average is 17.5%, so our weighted days becomes 1.575, okay? So again, what we've done is we're taking that weighted average approach and applying it to the entire process now, okay? So when we say in the entire process in terms of those that go through the excellent accepted phase and those that go through the excellent rejected phase, okay? So if we come back and we say excellent accepted, right? So excellent accepted goes through the initial review, which is 6 days, and goes through the excellent review, which is 3 days, okay? So that gives us 9 days total. And we have 175 applications through that process. If we look at the flow time excellent rejected, again, we still have 6 days and 3 days, and it still takes the same amount of time to reject. Okay. Flow time detailed review is the initial review plus the detailed review, so 6 plus 18 days is 24 days, and we have 25 applications through that. What you'll notice is all we're doing here with this throughput is we have a total of 250 that are going through the excellent process, right? And all we're doing here is saying we're breaking that into the accepted portion and the rejected portion. And we're doing the same thing with the detailed, right? We still have 250 going through, but we've just broken it into the accepted portion and the rejected portion, okay? And then the flow time for the initial reject is 6 days, and we have 500 of them going through that, right? So we can walk through that weighted average approach and come up with, okay, well, it's 11.25 is the average flow time, okay? Here's what I think is easier, okay? I can't sum these up because that doesn't work, because not every application goes through every step. But what I can do is use Little's Law and use, if I have the inventory and the throughput for the entire system, right? If I were to take, somebody take a calculator for me and take 375 and divide it by 33.33.
11.25.
Amazing. 11.25, right? So what happens is we can't sum it up, right? But we can calculate it because we have total inventory in the system and we have total throughput. And it comes back to be the same as if we were to do the weighted averages and walk through and do the individual weighted averages, okay? So I would much rather do this, right? But I wanted you to see that the results are the same no matter which approach you take, okay? So the key, again, you're going to hear me, this will be the third time I've said it, so is when you get to a nonlinear process, you can't sum the flow times to determine total flow time in the system. You can calculate it off of the average inventory and average throughput for the total system. And so you can calculate it, but with those figures, okay? So that's kind of the one of the key points of today's lecture, okay? And then basically they continue to walk us through this, but what if we want to know the average time for accepted or rejected applications? Well, now we've broken it down in terms of we have accepted, and we know that we have 9 days for excellent, and we have let's see, flow time. So if we want to know the average time for accepted or rejected applications, we've got flow time excellent accepted is 9 days. And then we also have those that go through the more detailed review that are also accepted, and they take 24 days. Okay? And so we do that same approach. We can take that weighted average approach here, and we can have 9 and 24 and 175 and 25. Gives us our days in each category, right, and gives us our throughput. And so we can calculate the weighted average, right? Or, Miranda, if you've got your calculator handy, what's 30, let's see, we would say this is 200 apps per month, right? And so if we would divide that by 30 days first, what does that give us?
6.66.
6 point what?
66. I'm going to pause on that because we should be able to do the math. I'll come back to that on Tuesday. There's a reason that we can't, and I'll come back to that. Okay? And so, again, we can keep working through and doing these weighted averages, right? And come up with, okay, what's our average flow time for rejected orders? Well, we have 3 categories of rejected orders. We have those that go into the excellent, right, and they get rejected. We have those that go into the detailed review, and they get rejected. And we have those that go into the just immediately. Yeah. Where is that second column coming from?
This apps through that process?
Yeah.
Okay. It is coming through here. So basically, you remember we said we have 250 that go into the flow time excellent. We come back to the diagram. What we know is, so we've got 25% that go into that excellent, and then 70% of those are accepted, and 30% of those are actually rejected.
Okay.
Okay? And then we have, coming into the detailed evaluation, we still have 250, and of those, we have 10% that are accepted and 90% that are rejected. So that's, we're using those percentages. I'm not sure I went over that as clearly as I should have. Okay? So, I mean, this is just the long way around how to calculate using the weighted averages. So what did we learn from this example? I want to make sure you understand the difference between linear and nonlinear. Linear is every flow unit goes through every step of the process. So your throughput is identical all the way across, right? Nonlinear is when basically you start to divide out and certain units go through certain phases, but they don't go through every step of the process. Okay, so when using Little's law, I can determine flow time through the system in a linear process, but I can't do that. I can sum it up, but in a nonlinear process, I'm not allowed to sum it up. I have to calculate it. Okay, all right. So let's look at another example.
That chart.
Do you guys, Julie and Miranda, do you guys have a question?
I was trying to figure out where you got the weighted averages from, but she showed me.
Okay, so if there's 1,000 applications and 250 of them go through, that's 25%. Or if I'm looking at 250 and 125 of them go through a certain step, that's 50%, right? So basically you're using the total number of flow units that go through the process that you're looking at, and then you're breaking it out into whatever percentage they are of that process. So, and that always has to total back to 100%.
Okay, so is that why? Because when you go back to the accepted orders, like when you had like just a little thing at the bottom, like the weighted averages were different than the top part. Is that because they have to add up to 1?
Yes, because all we're doing here is we're looking at these steps. And so 75 of 800 is 9.4%, 225 of 800 is 28.1%, 500 of 800 is 62.5%.
Okay, that makes sense. I just didn't know where you...
Didn't see where that was coming from? I'm glad you asked. Okay? All right. So here's another example. So a process example using Little's Law. So we have coming into, we're looking at a patient checking into a hospital, okay, or seeing a doctor, I guess is what we're looking at here, okay. And let me see if. Okay, so in this example, we have 4 patients per hour that are coming into the doctor's office, okay? And their first activity, and we know it's an activity because it's in a rectangle, they have a check-in process, and so that takes them 5 minutes, okay? Then there's a waiting area, and basically we have 2 patients in that waiting area, okay? Then we have an initial doctor consultation that takes 12 minutes, right? That's an activity, at which 25% of them are done with the process and 75% move on to a doctor request test for the patient. Okay, that takes 5 minutes. Then the patient waits, and then the nurse takes the test at the end of 30 minutes. Okay, so if we're going to fill that out, right, what's my throughput at the patient check-in?
4 patients per hour.
Right, so I'm going to go 4 patients per hour. Okay, and how many patients are waiting? What's my throughput there?
2.
Okay, is that my throughput or my inventory? Inventory. So I have 2 patients waiting, but what's my throughput for that process? It's still going to be 4 because every patient that comes into the process still goes through that, right? What's my throughput for the initial doctor consultation? 4 because everybody's going through that. Okay. What's my throughput for the doctor request test for the patient? 3, right? Because I've got 1 patient that's going here, and I've got 3, right, patients per hour that are continuing on for the doctor request tests. Okay, so then what's my throughput here for this waiting? 3, right? And then also here. And so, sometimes you just want to, if you're doing this and you've got your own diagram, right, you can, on these arrows, you want to put, that's what your throughput is, right? Okay, and so then I'm going to come through and start with my buffers, and I know that I have 2 patients in inventory at this buffer, and I have 1 patient in inventory at this buffer, right? And I know that my flow time at the patient check-in activity is 5 minutes. At the initial doctor consultation is 12 minutes. At the doctor request test is 5 minutes. And the nurse takes the test is 30 minutes. Okay? So are you tracking with how, when you use the table, it gets pretty easy to see where you've got 2 out of the 3, and then you just calculate the third, right? So in this case, inventory is equal to throughput times flow time, right? But what's my problem here? This is patients per... And this is in, right? So what I would need to do is divide each of these by 60 in order to convert that throughput to minutes. Chelsea, do you have a calculator handy? So could you do, so inventory is equal to throughput times flow time. So 4 divided by 60 times 5?
3.33.
3.33. Okay. 4 divided by 60 times 12.
0.08.
Okay. And then 3 divided by 60 times 5.
0.25.
And 3 divided by 60 times 30.
1.5.
1.5. Okay. All right, let's fill in over here. Khalid, do you have a calculator handy?
Oh, no.
I got different numbers for inventory.
For which one?
I got 0.33 for that for the first one, and then 0.8 for.
Okay, so 4 divided by 60 times 5.
I got
4
0.33.
divided by 60 is 0.06. And then
Yeah,
times
sorry.
5 is 0.33.
Okay.
I think it's just the decimals are off.
Yeah.
Okay, and then
That one I got 0.8.
all right. And are the rest of them?
0.25 is right.
And then 1.5?
That should be right.
Okay. So then, if I wanted to know the inventory in the entire system, right, I can add these up. So 2.33 plus 0.8. Would somebody do that for me? Then plus 0.25 plus 1 plus 1.5.
5.88.
5.88. So at any given time, on average, there are 5.88 patients in that entire system. Okay? Right? What's my total throughput for this system? So if I were to draw my rectangle, it would look like this.
Still be 4, wouldn't it?
Yep, because I have 1 patient exiting here, and I have 3 patients exiting here, so it's still 4 patients per hour. Okay? Right, so flow time. So if inventory is equal to throughput times flow time, then flow time is equal to inventory, something like that, divided by throughput, right? So if I were going to say then inventory of 0.2 divided by, and I need that in parentheses, 4 divided by 60. Excuse me, it's 2, it's not 0.2.
Okay, so
30?
30?
I think so.
This is 0.06.
Okay. So, and the other thing you could do is we could do the inverse of that, right? So instead of taking it 1 divided by 3 divided by 60, I can take 1 times 60 divided by 3. And so that should be 20 here. Everybody agree with that?
Yes.
Okay. So then, if I wanted to get my flow time, can I just sum these up?
Oh.
It should be a big no. Okay? But if I have 5.88 as my average inventory and 4 patients per hour as my throughput, I can then take 5.88 times 60 divided by 4. Would somebody do that for me?
Are you taking 60 divided by 4 or 4 divided by 60?
Well, so here's the thing. If I were to do 5.88 divided by 4 divided by 60, it's the same thing as taking
Okay.
5.88 times 60 and dividing by 4. So,
88.2.
say it again.
88.2.
88.2. So on average, a patient, regardless of what part of the process they go through, takes 88.2 minutes to go through the process. If I were interested in only how long does it take a patient that doesn't require patient tests, right, I could add up and say, well, it takes 5 minutes for the patient check-in, it takes 30 minutes to wait, and it takes 12 minutes for the initial doctor consultation. So that takes 35 plus 12 is 47 minutes, right? Okay, and so it takes that patient 47 minutes. Now, the other patient, the other 3 patients per hour go through every step of the process. So if we were interested in the average time for them, we could sum up every step in the entire process. And so their average time is going to be 35 plus 12 is 47, plus 5 is 52, plus 20 is 72, plus 30 is 102 minutes, right? So we've got 102 minutes for 3 patients, and we've got 47 minutes for 1 patient, right? Okay. So again, you can, by understanding how these components fit together, you can get a lot of information about a particular process. Okay, so what I'd like to do is I'm going to go ahead and we're going to take a look at some problems from the end of the book. Okay, we did 3.2 the other day, so I'll go ahead and start with 3.4. But I think the best way to show this is for me to actually put them up on the Elmo and draw them out. Because if I do them in Excel, I think that sometimes I can go too fast for what you're able to kind of keep up with. So that being said, look at you. You're on candid camera.
I would hate those things.
Oh, now I'm on candid camera. Try to get the Elmo on candid camera here.
77 to mine's only 87. Yep. I'm 10 pages behind.
And what book do you
I have
have?
the international version. So it was like $10.
Where'd you get that?
Online.
Oh yeah, we talked about that the other day.
I got all my books off of there, except for one of them. You get the international version of everything, but it's the exact same thing on the inside. I just don't know why I'm 10 pages off. I haven't figured that part out yet.
What's on the first 10 pages?
You know, mine's all of the vocab words.
Okay, give me just a second here.
Table of contents and everything.
I don't even have it. This is my table of contents. This.
And doesn't it not have chapters like on the
Yeah,
inside?
mine doesn't have chapters.
It's so weird.
It's the weirdest thing. Well, I think it might be like yours too. Mine's just like
Like as page
sections.
numbers, there's just no.
I don't
Yeah.
have vocab words.
See, I have vocab words in the front. Every vocab word. I know, it's pretty great. But like these definitions.
Okay. So let's start out with problem 3.4.
There's a lot.
Okay, and so one of the first things to do is to draw your diagram. And I think that if you draw the diagram, it makes the throughput easier to track with what's going on and just to keep your notes on it. So if we were going to read 3.4, it says a hospital emergency room is currently organized so that all patients registered through an initial check-in process. Okay? I'm just going to read it, and then you can maybe make notes as we go, and then I'll try to draw it up here, and you can see if yours matches what we end up with. So they have an initial check-in process. At his or her turn, each patient is seen by a doctor and then exits the process, either with a prescription or with admission to the hospital. Currently, 55 people per hour arrive at the ER, 10% of who are admitted to the hospital. On average, 7 people are waiting to be registered, and 34 are registered and waiting to see a doctor. The registration takes an average of 2 minutes per patient. Among patients who receive prescriptions, average time spent with the doctor is 5 minutes. Among those admitted to the hospital, average time is 30 minutes. Okay, so that's kind of everything that we've been told about this process. And so basically it starts out with, we've got, if I were going to draw throughput in, it's 55 patients per hour. Okay. And then we know, I guess what I'm going to just make a note up here, 10% admitted. And so that would mean 90% not admitted, right? On average, 7 people are waiting to be registered. So I'm going to draw my weight. And we know that we've got 7 patients here. And if they're waiting to be registered, that's probably the next step. So to be registered. And the registration process takes on average 2 minutes. Okay? Among patients who receive prescriptions, average time spent with the doctor is 5 minutes. Okay? So if I'm receiving a prescription, I spend 5 minutes with the doctor.
Can you like zoom in on that? Like I can't see anything.
It's a little blurry.
Yeah,
blurry.
because it can.
I know my eyes are closed.
Yeah, I don't know why it's so blurry.
There we
There
go.
we go.
Except for now, I have to go a little wider. Okay. And so then as I'm writing, if it gets to where you can't see it, just give me a reminder, because as I'm looking at that, I'm not always as aware of what you're seeing. Okay, so we've got that among the patients who receive prescriptions, they spend 5 minutes with the doctor. Among those admitted to the hospital, so now I've got, okay, we've got a doctor admit. They spend 30 minutes. Okay? And so then I've got my 55 patients per hour on my first arrow. So that's how many patients go through this buffer 1. How many patients go through the registration process?
55.
Right, so I'm going to put 55 here. Okay, I say that there are 10% that are admitted, so 10% go this route, which means that 90% go this route. So what's my 10% admit? How many patients?
5.
I heard it.
5.5.
5.5, right? All I'm doing. And so if it's 5.5 here, then it's going to be 55 minus 5.5 up here, the remaining 90% up here, right? And so I think that would be 49.5. Everybody agree with that?
Yes.
And so you can see then I still have, exiting the process, I still have my total of 55 patients per hour. But they're going through 2 different steps, okay, as they exit that process. So now that I've kind of got my drawing set up, I want to set up my table, okay? And so if you're setting up a table, what do we want to do with our table? What goes on the left side of the table?
The steps.
Activities and
Every step in the process. So I'm going to start, and I just typically call this buffer 1, and I think that's the only buffer. Oops. It also says, I think I missed it. Let's see.
Oh yeah, they're registered and waiting
Wait
to
to
see
be
the doctor.
registered. The doctor.
Oh no, I don't want to redo this.
34 are registered and waiting. I'm sorry, there should have been, you love me, another buffer here. So buffer 2 should have 34 people waiting in it.
I drew it in pencil, but I don't want
I'm
to
really
erase it.
sad about this now.
So as I put my steps, I'm going to have buffer 1. I'm going to have registration. I'm going to have buffer 2. I'm going to have doctor with prescription. And I'm going to have doctor admin. Okay, so those are the steps that I have in the process. All right, then I need to have inventory.
Really did. That's great.
throughput, and my throughput is in patients per hour, but my flow time is actually in minutes. So I know that I'm going to need to convert to patients per minute. So I'm going to use a second column for my throughput, right? And then I've got my flow time, which is in minutes. Okay? So now I start to just fill in the information that I know, right? And so I know that at buffer 1, my throughput is 55 patients per hour. At registration, it's 55 patients per hour. At buffer 2, it's still 55 patients per hour. At doctor prescription, right, it's 49.5. And at doctor admit, it's 5.5. And I know that my total is 55 patients per hour. Right? Everybody tracking with that? Okay. Then in terms of inventory, at buffer 1, I know that I have 7. At buffer 2, I have 34. Right? For activities, for flow time, at registration, I know that it takes 2 minutes. At doctor prescription, I know that it takes 5 minutes. Right? And at doctor admit, I know that it takes 30 minutes. Okay? And if we look, I can go, okay, I've got 2 pieces of information for buffer, 2 pieces for registration, two pieces for buffer 2, 2 for prescription, 2 for admit. She says, as though she's got 30 minutes written for admit, right? So I can flip down through that and I can see I've got 2 pieces of information for every item in my table. Now I just use Little's Law and finish out the calculations, okay? And so the first thing I want to do is I want to convert to people per minute. So if I were to divide 55 by 60, magically I know that's 0.9167 patients per minute. And the doctor admit at 5.5, right, is going to be 0.09167. And the doctor prescription is going to be 0.8250. And that's just by taking 49.5 divided by 60 and 5.5 divided by 60. And in total, it's still going to be 0.9167. Okay? So, if I'm going to calculate inventory, inventory is equal to throughput times flow time. So I'm going to take 0.9167 times 2. And it should be 1.83. I'm going to take 0.8250 times 5. And it should be 4.13. Everybody agreeing? Anybody checking my math?
When we do these, like, what is like the standard for what we round to? Do you care?
If you, like, on the throughput like that, I think 4 decimal places is good on that, okay? Because otherwise you're not going to necessarily always see the nuances of the difference. And then in terms of inventory and flow time, 2 decimal points is probably fine, okay? And I don't get hung up on that. I mean, it's when you do your exam problems, I just follow through but I'll try to be specific on the problems, okay? So then for doctor admit, I'm going to take 0.09167 times 30, and that should be 2.75. Okay? So then I can sum up, right, my inventory. And so my average inventory in the entire system is 49.71. Okay? And so I've got my average inventory in the entire system, right? And I have my average throughput, so I can already calculate that the average flow time is 54.23 minutes. Okay? But I want to finish my table out as well. And so flow time is equal to inventory divided by throughput. So flow time for buffer 1 is inventory of 7 divided by throughput of 0.9167 gives me 7.6 minutes. Okay. Flow time for buffer 2, inventory of 34 divided by 0.9167 gives me 37.1 minutes. Okay.
And so the question asks us then, on average, how long does a patient spend in the ER? How long does any patient spend in the ER? 54.23. On average, how many patients are being examined by doctors? How would I determine that?
Would be the inventory.
Be the inventory of the two doctors, right? So I've got it, or the two doctor steps. So it would be the 4.13 plus 2.75. Okay. On average, how many patients are there in the ER? And so we can just sum up the total inventory to say on average there's 49.71. And so again, the last thing they say is assume that the average inflow rate equals the average outflow rate. Okay, so that being said, I'll show you and you can tell me which you would prefer. Okay, so this is what it looks like when I do it in Excel. Okay. But I know that the speed is probably better when I handwrite it. So, do you have a preference? How many would rather see it in Excel? How many would rather see me handwrite it? Okay. All right. I'll handwrite it. And then what I'll do after class is I'll post the Excel document. Okay. So that way you can kind of refer back to that if you've got questions. All right. So that was problem 3.4. 3.5 builds off of 3.4. Okay? And so 3.5 says a triage system has been proposed for the ER described in exercise 3.4. Under the proposed triage plan, entering patients will be registered as before, and they will then be quickly examined by a nurse practitioner who will classify them as simple prescriptions or potential admits. While simple prescriptions will move on to an area staffed for regular care, potential admits will be taken to the emergency areas. Planners anticipate that the initial examination will take 3 minutes. Okay, so the first thing to do is revise our diagram. Okay, and so we still have, it doesn't say it in this problem, but it's based off of 3.4, and our throughput in 3.4 was 55 patients per hour. Okay, so we've got this coming in, 55 patients per hour. Okay, and we have this buffer 1 where they're waiting. And we have 20 patients waiting. And then we have a registration, which takes 2 minutes. Okay. And then we have another buffer, which we have 5 people waiting at, 5 patients. And then we have this triage step, which takes 1 minute. Okay? And then after triage, they wait. Right? So we have buffer 3 and buffer 4. In buffer 3, we have 15 patients waiting. And that leads to our doctor that's going to give the prescriptions. And buffer 4 leads to the doctor with the admit. Again, that's an activity step, and that's an activity step. Okay, so we've got 5 minutes here, and I've got 30 minutes here.
Is there a number for buffer 4?
Yes, there is. Buffer 4 has 1 person waiting. Okay. All right, so then to follow through with kind of how we approach this, I'm going to put my steps of the process down the left side of my table. So I'm going to go buffer 1, registration, buffer 2, triage, buffer 3, doctor with a prescription, and then buffer 4 and doctor admin. So, and at the top, I need to put inventory, throughput, And again, my throughput is in patients per hour, and my flow time is in minutes. So I need 2 columns for my throughput, and I need 1 column for my flow time. All right, so I'm going to start out with, maybe the best thing to do is to come up here and to put on these arrows what my throughput at each of these steps is. So it maintains 55 patients per hour all the way to triage, right? And at triage, we know that 90% of all patients need a simple prescription. So again, that means that 10% need to be admitted. So I've got 5.5 on the admit route and 49.5 on the prescription route. So I can then translate that into my table. So at buffer 1, my throughput is 55. At registration, it's 55 patients per hour. At buffer 2, it's 55. At triage, it's 55. At buffer 3, which is where we split off, it's 49.5, and doctor prescription is 49.5. Buffer 4 is 5.5, because that's my 10% going to admit, and so then I have 5.5 there. Okay, so my total for this system is how much? It's my total
55.
throughput? 55 patients per hour. Okay? All right, and because we did the calculations before, we know that 55 patients per hour is 0.9167 patients per minute. And we know that 49.5 is 0.8250. And we know that 5.5 is 0.09167. Okay. So now I've got my throughput entered across the board. I'm going to come back and enter my patients at each buffer. Buffer 1 has 20 patients. Buffer 2 has 5 patients. Buffer 3 has 15 patients. Buffer 4 has 1 patient. My activity times, registration takes 2 minutes. Triage takes 1 minute. Doctor prescription takes 5 minutes. Right? And doctor admit takes 30 minutes. Right? And so now what I can do is I can look down my table, and I've got, again, 2 out of 3 pieces of information for every step in the process. I'm going to use Little's Law to continue to figure it. Okay? So if I were going to figure inventory at registration, I'm going to take throughput times flow time, 0.9167 times 2 is 1.83. 0.9167 times 1, 0.92. 0.8250 times 5, is 4.13. And 30 times 0.09167 is 2.75. Okay, and again, I can sum up my inventory to get my average inventory in the entire system, and that should be something like 50.625. Okay. All right, then to complete the table, I need to fill in how much time it takes at each step. Okay, so we know that flow time is equal to inventory divided by throughput. So 20 divided by 0.9167 is 21.8 minutes. 5 divided by 0.9167 is 5.5 minutes. 15 divided by 0.8250 is 18.2 minutes. And 1 divided by 0.09167 is 10.9 minutes. Okay? Can I sum up the flow times to get my average flow time? I cannot. So what do I want to do to get my average flow time for the entire system? I want to take the inventory of the entire system divided by the throughput of the entire system. So that's going to be 50.625, right, divided by 0.9167. Okay, and at the end of the day, that says 55.23. All right. So the question that we want to ask ourselves is, first off, how long does a patient spend in the prescription process, right? And what we're going to do is we're going to sum up everything from buffer 1, registration, buffer 2, triage, buffer 3, and doctor prescription. Okay? And if I sum those up, that's going to tell me that that's 53.5 minutes. So from a 90% of the patients are going to take 53.5 minutes through the doctor prescription process. Okay. On the other hand, I need to sum up buffer 1, registration, buffer 2, triage, and then add to that buffer 4 and doctor admit, right, to get the entire time that it takes for somebody to go through the admit process. All right, and so then I have 10% of my patients going through that admit process, and it takes 71.2 minutes when I sum those up. Okay? And so what I did is they went through each of these steps, right, to get to the 71.2 minutes is what I did, is I just added up each of those steps individually. Okay? So before we revised this process, we said that on average that a patient spent 54 minutes in the entire process. Okay? And so now with this revision, right, we're saying that a patient spends on average 55 minutes in the entire process. Okay? So then the question is, did we improve the process? Trying to think then, let's see. We said that in the previous process, what was our doctor admit route? We would have said, give me just a second. We're going to look at that doctor admit real quick. So in this process, we said that it would take someone that was getting admitted, it would be, they'd have to go through buffer 1, right? Buffer 2, or the registration process, buffer 2, and then doctor admit. So in that scenario, that patient that was getting admitted to the hospital took 76 minutes. In the scenario that we just described, it takes 71 minutes. Okay? So you'd say that for that patient, for those patients getting admitted to the hospital, right, we're improving the process by 5 minutes. Okay? For those patients that are going through all the steps in the process, right? Or excuse me, so we have 53.5 minutes for those that are getting prescription with the revised process, And those getting prescription here would have been, they'd go through buffer 1, they'd go through registration, they'd go through buffer 2, and then they'd see the doctor for prescription. And so 51.7 minutes as compared to 53.5 minutes. So we're not improving the process for them. We're basically disimproving the process for them. Okay. So you have to ask yourself, is revising that process worth it? And I don't know that I'm qualified to answer that. I think if you're talking about if you're being admitted to the hospital and you're saving someone 5 minutes, that probably matters some, but is it enough to justify the change in the process, right? So again, there's not always a clear-cut answer. You have to be kind of in the know in terms of that industry to know whether or not that would be worth it or not. But those are the kinds of questions that you're trying to make comparisons on, right? So you want to do this, and you're going to probably, spend some extra resources with the triage nurse now kind of making that decision. And so is that going to be a good call or not? So I'd have trouble justifying it based on what we just looked at, right? For 5 minutes for somebody being admitted to the hospital. On the other hand, maybe because of my experience at hospitals, that 5 minutes here doesn't necessarily mean 5 minutes picked up in the entire process, right? You get in and you wait. So, again, food for thought in terms of how you would approach a problem like that. All right. In problem 3.6, what they say is, okay, and I'm just going to show you this one. We're not going to walk through all the steps of it. But in 3.6, what they say is, okay, your triage nurse makes a mistake, okay? Your triage nurse says that 91% of the patients that he or she sees goes through the prescription process. But once they get to the doctor at the prescription process, the doctor says, nope, there's 1% of those patients that were misdiagnosed, and they need to go back and then be admitted to the hospital, okay? And so how that changes is you take your diagram, right? And so our diagram looks just the same as what we drew before, except for now we have 91% coming up to doctor prescription and 9% going down to admit. And then out of doctor prescription, we have another 1% coming back into doctor admit. Okay? And so when you figure the throughput for these steps, right, your throughput for this buffer is all of the inbound arrows. So you look for inbound arrows and you say, well, it's 9% and 1%, so it's 10% of the total throughput. Okay? So that's kind of the key. You're looking for all of the inbound arrows to determine the throughput for that step. Okay? And then out of that step into doctor admit, then is the 9 plus 1 or 10%. And so then as we create, right, our throughput, we know it's 55 patients per hour at buffer 1, at registration, at buffer 2, and at triage. But now, instead of 90% going into buffer 3, we have 91% going into buffer 3. And then we have 10% coming into buffer 4 based on the 9% plus the 1%. All right, is everybody seeing how that changes the diagram and how we change then our throughput? And once we've changed our throughput, right, then we just revise our calculations based on our revised throughput. Any questions about that? You seeing how that? Okay. All right. Is that a yes, no, maybe? Abby?
I got it.
You got it? Okay. All right. All right, let's then, let me flip back to this. And let's take a look at a little different type of problem, which is problem 3.9. Okay, and so in problem 3.9, we're going to talk about cheapest car rentals. Okay, and we have a drawing at the top for what cheapest car rentals looks like. And so basically they say we have a customer, we have a cleaning process, and we have a repair process, And so our customer takes the car. We have a buffer waiting to go into the cleaning process, and we have a buffer waiting to go into the repair process. So this is about a rental car agency. And what happens with these cars and how profitable this is. Okay? And so, again, this is just figure 3.9 from your textbook on page 78. Okay? And so cheapest car rentals rents cars at the Chicago airport. The car rental market consists of two segments. The short-term segment, which rents for an average of a half a week. And I'm just going to make some notes. Short-term rents for half a week. Okay? And the medium term, which rents for 2 weeks. Okay? Cheapest currently rents an average of 200 cars per week to the short-term segment. What does 200 cars per week represent to you? There you go. Okay? And 100 cars per week to the medium term. Okay? Approximately 20% of the cars returned, evenly distributed across both segments, are found to be defective and in need of repairs. So we know that we're going to have, I'm going to just put 20% here, which should tell me what is going into the cleaning process then. 80% going into the cleaning process. Okay? And the remaining cars not needing repairs are cleaned, filled with gas, and made available for rent. On average, there are 100 cars waiting to be cleaned. So I'm going to have 100 in that buffer. And the average cost of cleaning, so cleaning, we have inventory. You said that was 100, and we have our cost. And I'm going to revise this to fit our table, and the average time spent in the repair shop is 2 weeks. Okay? And assume that on average the cost of a repair is $150. Okay? Short-term renters pay $200 per week. So my revenue from a short-term is $200 per week. And my midterm renters pay $120 per week. So this is dollars per week. Okay? So then it says, identify the throughput, inventory, and flow time at each stage. All right? I'd have been better served if I would have just put my time out to the right. But when you're taking notes, sometimes you're not always 100% sure of how it's going to flow out. So I'm going to go ahead and say that my stages are going to be, I'm going to have a short-term customer. I'm going to have a medium-term customer. Right? We're going to have cleaning, and we're going to have repair.
Should it cost them anything to repair it? Because
Okay, so for my short-term customer,
they pay for insurance on the car.
what I know, if I were going to talk about inventory, throughput, and flow time, is that my short-term customer has 200 cars per week, and they rent them, on average, their flow time is a half a week. My medium-term customers have throughput of 100 cars per week, and they rent them for, on average, a flow time of 2 weeks. Okay? In terms of cleaning, okay, I know that I have 300 cars per week going through the rental process, right? And of those 300 cars per week, 20% of them are going through the repair process. So 300 times 0.2 gives me 60. Which means that the remaining are going through the cleaning process. So 300 minus 60 gives me 240. Okay? So I've got my throughput established, right? So I'm looking then for what else do I know about cleaning and repair? Well, I know that I have 100 cars in inventory at the cleaning process, and I know that the repair process takes me on average 2 weeks, right? And all of that came from the problem that we were given. And so it's just about how can you frame your information here, right? So if I look, I've got 2 out of 3 pieces of information for every location. So my short-term customer inventory is going to be 200 times 0.5, which is 100 cars in inventory there. My medium-term customer inventory is going to be 100 cars per week times 2 weeks, gives me 200 cars in inventory there. And my repairs are going to be 60 cars per week times 2 weeks, should be 120 cars here. Okay. For time, right, it's going to be inventory divided by throughput. So 100 divided by 240 is 0.42 of a week here. Okay. So my total cars in inventory, 100 plus 200 is 300, plus 100 is 400, plus 120 is 520, right? So I have 520 cars in total, right? And my throughput is 300 cars per week. And so I can figure my average flow time, if I wanted to say 520 divided by 300 is 1.73 weeks. So we've got throughput, inventory, and flow time identified at each stage. And then it says, well, what profit does cheapest earn per week with the current system? Okay. And as part of that, we want to assume that each car loses $40 in value per week because of depreciation. Well, if I'm interested in that, right, I need to know the revenue. I need to know some costs and some revenue. Okay. And so what I know is that I am that our revenue per car for short term is $200 per car. Okay? And if that's the case, what am I going to multiply that by in order to determine my revenue?
How many cars a week?
Okay? It's going to be by inventory, because that's how many cars are in that snapshot. If I look at that on a weekly basis, on average, I have 100 cars that are in short-term rental every week. So I'm going to take my inventory of 100, right, times $200 per car, and that's going to tell me that my revenue there is $20,000. Okay? And on that same note, my revenue for my medium-term customers, we know that I get $120 per car, and I've got 200 cars there. So that's going to give me $24,000 in revenue there. Okay. And then if I'm looking at my expenses, I know that it costs $5 per car to clean, and I know that it costs $150 per car. Okay, so here's where it gets a little interesting, because we used inventory. You have to think about what each measure represents, right? We used inventory for the revenue purposes because we're saying on average that's the snapshot of cars that are there in a given week. Okay. When we start to talk about the expenses, we want to know how many cars are flowing through that in a week, right? And so we have to take our expenses times the 240, right, for our cleaning, that's how many cars are going through that process every week, okay? And we're going to multiply it by our $5 per car, okay? So that being said, our weekly cleaning expenses, so $5 per car times 240 is going to be $1,200, and $60 per car times 150 is going to be $9,000. Okay? And I think it's going to get easier because you're going to be able to see more if I now transition over to Excel. So I'm going to do that. Okay, so here's that table that we just put together, right? Here's our total revenue, right? Here's our total expenses. So if I say that I have $44,000 in total revenue, and oh, by the way, we need to take into account depreciation, because remember it told us that we had $40 per week per car for depreciation. Okay, so 520 times 40 gives us $20,800 in depreciation. So our total costs then are the cleaning, the repairs, and the depreciation summed up. Okay, and that tells us that we have $13,000 per week in profit. I will tell you, I will not give you anything this complicated on an exam. So don't start stressing that this is what you're going to see on an exam. What I do want you to see is the multiple ways that you can use it and how you have to think through what does inventory represent, what does throughput represent, right? And so then they ask the question, oh, we're over time, aren't we? Yeah. Sorry. You get to flag me down if we do that. All right, so there's going to be some questions on your homework about inventory turns. Take a look at the PowerPoints that are out there because we didn't get to those today, and I think you should be able to walk through those. Do the best you can, post your answer, and then correct it based on the posted solution, okay? And we'll finish up with that part of the lecture on Tuesday, and we'll go through some practice problems, okay? The homework that you have is not this complicated, so it's going to be the nonlinear type approach, so you should be in pretty good shape. All right, ready? Great.